In this video, we'll look at how to create numeric buckets of equal density. Let's take a look at this sample data set. We have 10,000 rows of data, and they follow a bell curve, normal distribution. It's randomized data. In this histogram above, we can see how many values we have along this scale here, between roughly 40 and 160. And if we'd like to split up this big bar of 10,000 values into, for example, 10 buckets of approximately the same number of values, we can create an equal density numeric bucket. So we press Edit Data Table, we select the data source, and we go to the Calculated Columns pill. We say New Column and Numeric Bucket. And let's give it a title, which should be equal density, to explain what it is. The source column is value, and what we want to do is an equal density bucket, and let's say we create 10 buckets. We press refresh preview, and we see this new column right here. Press save and back. And we now have this column here, equal density, that we can apply to the bar chart below to split up this big bar into 10 bars. So we select that bar chart, breakdown, equal density, we pull it to items, and we now have this bar chart of 10 bars which have a number of members, because what we've done now is, to our best ability, we've split up this data set into 10 chunks, and the effort is to get as close to 10,000 divided by 10, that is 1,000 members of each bar. And you can see that in some cases it's not possible to make a cutoff between any two of these integer values to achieve exactly 1,000 members in each bar, so we get some variation. But we can also compare with how these equal density numeric buckets come out when we have a different value distribution. So right here we have again the same bell curve, and we see this slight variation in the number of members of each of the 10 buckets. In the middle we have a more uniform random distribution, and we can see that the variation is slightly less. We have a better chance of finding a cutoff, which takes us to a number closer to 10 in terms of records that end up in each of these bars. And if we look at this data set, which is a perfectly flat or even sample, we can see that naturally each of these equal density bars get exactly 1,000 members, because in here we have a uniform repetition of values between 50 and 150 repeated 100 times, equaling 10,000 values. So we can find cutoffs that takes us to exactly 1,000 members in each of these buckets.